to my math class. In the previous lecture on set theory, we studied about the definition of set theory. What was the definition of set theory? A set is a collection of well-defined objects. Yes, and we gave some live examples on that. What else did we study? We studied different types of sets. What were those? Infinite set, finite set, null set, singleton set, subset, and power set. Yes? Now in this video lecture, let us solve some problems on set theory. As you can see, I've already written a problem that says that x is equal to x such that x is equal to n cube plus 2n plus 1, where this n belongs to the set of real numbers. Yes? Now as you can see that this is in property way, right? And they've given another set, that is y, where x is equal to 3n squared plus 7. Even here n belongs to the set of real numbers. They are saying then this x intersection y is a subset of any one of these sets. Yes, it can be a subset of any one of these sets, or none of the above can be a subset of x intersection y. It is our job to find it. Yes, to begin with, let me take, yes, I begin by saying x belongs to x intersection y. Okay, and I'm writing n cube plus 2n plus 1 is equal to 3n square plus 7. Now if you ask me how did this step come, let me take an example for that. Say a is equal to 1, 2, 3. Yes, b is equal to 3, 4. Yes. Now what is a intersection b? A intersection b is equal to 3. Right? So if there were only this element, I would have written a is equal to b is equal to this element 3. Yes? So now that is what I've written here, right? n cube plus 2n plus 1 is equal to 3n squared plus 7. That is x intersection y. Okay? So now let me simplify this. We would get n cube minus 3n square plus 2n minus 6 is equal to 0. Yes, taking out n square common, I would get n minus 3 plus 2 common, again I would get n minus 3. So I can write n square plus 2 into n minus 3. Okay, this is equal to 0. Now, what is the value of n? Can it be 2 or 3? So I'll directly write that n is equal to 3. If you ask me how, let me simplify n squared plus 2. N squared plus 2 is equal to 0. Then I would get n is equal to minus 2. Yes, what would n be? That would be plus or minus square root of minus 2. Yes, so what is square root of minus 2? It is square root of 2 into I. Does this belong to the set of real numbers? No, right? This belongs to the set of complex numbers. So n is equal to 3 belongs to the set of real numbers. So the value of n is 3. Now using this value of n, Let me find the value of x. Yes, let me take one of these equations that they've given in the question. Okay, let me take the second one for now. That is x is equal to 3n square plus 7. Yes, what is the value of this? 34, right? So, now we have the x value. In the given question, check for which value of n you would get 34. Let me take the first one. Yes. So for the first one, x is equal to 3n plus 5. What if I give the value of n as 10? I would get 3 into 10 plus 5. That is 35. This is not equal to 34, right? So A is not the answer. Okay. So let me take B. That is x is equal to n square plus n plus 1. Let me give the value 5. What would that be? I would get 25 plus 5 plus 1. Right? So what would the answer be? 31. So is this equal to 34? No, right? This is not equal to 34. So let me discard option B2. Yes? Now let me take the third one. That is x is equal to 7n minus 1. What possible value can you give? Let me give 5 itself. I would get 7 5s are 35 minus 1. Right? So what did I get? I got 34. Yes, so I got the x value for the third one. So your answer is C, where n is equal to 5. Yes? Moving on, let us switch to the second question now. That is, if A, B, C are non-empty, okay, A, B, C are non-empty means there are some elements in these sets A, B and C, okay, such that A intersection B is equal to null. What do you mean by this A intersection B is equal to null? It means that A and B, that is the elements of A and elements of B are not the same, not even one element is same. And B intersection C is also null. For example, let me take a set like that. Okay. Let me say A is equal to 1, 2, 3. Yes. B is equal to 11, 12, 13. Yes. And C is equal to 21, 22, 23. Yes. Now, is A equal to C? Are the elements of A and C equal? No, right? Is A a subset of C? Are the elements of A present in element that is in the set C? No, right? We have 1, 2, 3 here, but we don't have 1, 2, 3 over here. Right? Is C a subset of A? Is 21, 22, 23 present in A? No, right? So the answer for this question is D. That is none of the above. Okay? Moving on. In the third question, they've said two finite sets have m and n elements respectively. So how do you? Okay. The total number of subsets of first set is 56 more than that of subsets of the second set. How do you denote the total number of subsets? We studied about this in the previous video, right? Okay. So total number of subsets of first set is 56. So which is the first set over here? M, right? So first set is M. So how do you denote this? I denote this by 2 to the power M. Say, okay. Now they are saying the total number of first set is 56 more than that of subsets of the second set. So I can write 2m is equal to, yes, 2 power n plus 56, right? So what does 2 power n denote? The number of subsets of the second set, that is n. Okay, simplify this now. How can you write 56? Can you split 56? Okay, let me divide this by 2 now. 2, yes, 2 14s and 2 7s. So can I write 56 as 2 cube into 7? Yes. So let me write 2 power n plus 2 cube into 7. Yes. So 2 power n minus 2 power n divided by 2 power 3 is equal to 7. Okay. So after this, let me divide 2 power n. If I can either write divided by 2 cube or I can write minus 3. Okay. Minus 2 power n minus 3 is equal to 7. Now let me take 2 power n minus 3 common. What would I get over here? I would get 2 power m minus n. If you ask me how do you get this, just multiply these both. Okay, 2 power n minus 3 into 2 power m minus n. What would I get? Since the bases are same, I can add the powers. Yes, I would get m minus n plus n minus 3. N and n gets cancelled and I would get 2 power m minus 3 back. Yes. So now you see here, can I equate? How can I equate these both? See, 7 is a prime number. I cannot split it anyway. So let me take it as 1 itself. Or in anything to the power 0 is 1. Agree? So can I write here as 2 power 0? Yes. So I have same bases over here. Let me equate the powers. Okay. 2 minus 3 is equal to 0. So what is the value of n? We got value of n as n is equal to 3. Okay. So from this equation, let me substitute n is equal to 3 in this equation. Okay, let me name that as equation 1. Yes. Now from equation 1. Equation 1, we have 2 power m is equal to 2 cube plus 56. What is 8 plus 56? 64, right? So again, divide 64 with 2 and can you tell me how much you would get? Yes, 32, 16, 8, 4, 2, right? So 1, 2, 3, 4, 5, 6. I can write this as 2 to the power 6. I have 2 power m over here. So the value of m is 6, right? Now from this, can you find out the value of n? We have the value of m. What is the value of n? From where can you find the value of n Okay, so we've already found the value of n, right? M is equal to 6 and n is equal to 3. So your answer is B, right? 6, 3. Yes? Okay. So the next question is A is equal to 1, 2, 3. B is equal to 3, 8. We have to find A cross B. Okay. So what is A cross B now? We solved one such type of problem in the last video. Yes. So A cross B would be the ordered pairs. That is 1, 3. Yes. 1, 3, 1, 8. Right? 1, 8, 2, 3, 2, 8. Yes. And then comes 3, 3 and 3, 8. Right? So how did we solve the first problem? We equated the two equations because it is they've given x intersection y. Yes. Using that n value, we substituted it back and we got a x value. Yes. That x value, we put some n values for the given question to check if we would get this x value, and we found that the C option was right. Okay. So in the second one, they've already mentioned that A intersection B is equal to null, right? And B intersection C is equal to null. So we wrote down three sets, okay, where A intersection B and B intersection C is equal to null, and we saw that none of the above is true. Yes. For the third one, they have mentioned that the total number of subsets of first set. So which was the first set? M, right? 2 power m. So that is how we denote total number of subsets is equal to, okay, they've said that this is 56 more than that of subsets of second set. Which is the second set? N, right? So we got 2 power n plus 56. Yes. So after simplification, we found that n is equal to 3. So substituting this n is equal to 3 in the first equation, we got the value of m. And in the final problem, we found the Cartesian product. Yes, that is it for today's class. Thank you.